Hello learners, today we start a series of optics. Can you see an object in dark? No. Why? Because only the light which helps to see each and every object in the world. Light falls on an object and it reflected and enter in our eyes. This is the way we see in this beautiful world. In the field of physics, which study the propagation of light and nature of light, is known as optics. Let's start the journey of optics. It can further be divided into two main branches: geometrical optics and wave optics. In geometrical optics, the obstacle sizes are much larger as compared to wavelength of light used. This branch mainly deals with image formation by mirrors, lenses and prism. The four fundamental properties of light are straight path of light, rays of light have their independent existence, laws of reflection are obeyed, when light changes its medium, changes its path, and law of refraction means Snell's law is obeyed. Geometrical optics fails to explain the phenomena of interference, diffraction. These can be explained on the basis of wave nature of light, where the obstacle size are almost comparable to the wavelength of light used. Interference, diffraction and polarization are three main phenomena studied under wave optics. Many of us keenly observe beautiful wave pattern with the ripples on water surface in a pond, tank or lake. Instead of water surface, the light also produce such patterns. Two beams of light cross each other and present a beautiful modified view of pattern. Third field of these modification is related to sound. When two amplifiers working, then the interference of sound is happened. Two or more beams of light gives a combined effect, that is a modification of intensity of light, is known as interference of light. Interference is nothing but redistribution of light intensity and is very much tuned with the conservation of energy of instant wave. It's two types: constructive interference and destructive interference. Interference can only be understood by studying the principle of superposition. Here I showed the superposition of two waves. This is a constructive. For constructive condition, amplitude of waves in same direction and equal. Now we see example of destructive interference in amplitude equal but opposite direction. Again, clearly watch. The destructive shows 0, then momentum transfer, which one up that becomes below and which one below it becomes up. If amplitude of both waves are not equal, the resultant wave have low amplitude as compared to both. Now we see the superposition in below 1. It's a time to have a look on the theory of superposition. Here we represent phi1, phi2 for two waves. The resultant of these two waves shown by psi, which is equal to sum of amplitude and phase. Now intensity is the square of the psi. After solving the problem of intensity, which gives the value I is equal to I1 plus I2 and plus J12, and this J12 is known as interference term. Here I want to show you one more activity which is available on WaveAdd HTML5 Wave Addition Simulator for physics teachers. We can play with waves on this simulation. There is large option mentioned on here: standing L, standing transverse, destructive, constructive. I choose constructive. Now you can see beautiful pattern of constructive wave. Click of destructive, we see 1 plus 2 show no wave, or for standing transverse Then standing longitudinal, we can observe beautiful pattern as we change its amplitude, frequency. So many options are available here. Combination of longitudinal with transverse, we see the beautiful pattern again. In next video, we will cover the topic Young's double slit experiment, Fresnel biprism.